Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. This is question 6 under a May-June 2022 question paper. So, question 6 says to us, let me try to zoom this out a little bit. All right, question 6 says, the sketch below shows the graph of f of x. It is equal to negative x squared minus 6x plus 7. C, it is the y-intercept of f here. All right, we can see that a and b are the x-intercept of f. Let's see, a and b are the x-intercepts. That's true. Then d, it is negative d of coordinates negative 5, and k is a point on f. This is what we see. All right, so the information that we are given here, all of it is there on the sketch. All right, so now 6.1 says calculate the coordinates of e, the turning point of f. Now the coordinates of e, the turning point of f. Remember, if you have already done calculus, you know that at the turning point, what your gradient it is equal to 0. But we know what is the gradient. The gradient it is the derivative, the first derivative of a function. So the first derivative of this function should equal to what? Should equal to 0. So I'm gonna say, what is the derivative of this function? When I derive, remember it says 2 multiplied by negative 1, it is negative, all right? For those who are not so sure, negative 2x. Then remember, if it is negative like this, how do I derive? I multiply whatever these two with the coefficient here, it is negative 1. It's going to be what? Negative 2x. Then these two here, I just subtract 1. It's going to be 1. So hence I'm saying it is negative 2x, right? Negative 2x. Then when I derive negative 6x, it gives me negative 6. It is equal to 0. Then when you solve mathematically, x it is equal to how much? X it is equal to 3, right? X it is equal to 3. So this is the x coordinate here, and you should make sure that your answer makes sense, right? Yes, it does, because it is on the negative x values. So how do I get y? I take this x and substitute it on this equation. I take x and substitute here, right? So when I do that, when I substitute a negative 3, I'm going to negative this negative of this sign, right? Negative, then when I substitute, I put the bracket, whatever that I'm substituting inside the bracket, minus 6 into negative 3 plus 7. Then the answer that I get here, it is how much? It is 15, right? Let me just confirm that. I think it's 15. Rather 16. I get 16. So I get 16 here. Let me just do that again. Negative 9 minus, yes, I get 16, right? So it means now the coordinates of E are going to be x it is equal to negative 3 and y it is equal to 16, right? So I have the coordinates here of our turning point as negative 3 and 16. Let's assume that when you do not understand calculus and you want nothing with it to do, you want nothing to do with calculus. So the method for you is that, for turning point, this is the axis of symmetry, right? And how do I get the axis of symmetry? If I want the x here for axis of symmetry, remember I'm gonna say x it is equal to what? Negative b divided by 2a, right? I'm going to say negative b divided by 2a. What is negative b? Remember this is a, this is b, this is c. What is negative b? It's going to be negative into what's b? B, it is negative 6. So negative 6 here. 2. What is a? A, it is negative 1. Negative 1. So 6 divided by negative 2, it is negative 3. Then you also apply the very same method. F of negative 3, you substitute there. This 3 here, then you get what? You get 16. So whichever method that you prefer, please make sure that the sort that you are using is the one that is going to collect marks for you, all right? This is negative 3, okay? So, yeah. Right, let's see. 6.2 says write down the value of k, write down the value of k, write down the value of k, write down the value of k. So, all right, remember this point, it is a point on this function, right? But we know the x value, so let's find the y value by substituting 5 here. So let's substitute -5. It's going to be negative into -5 squared minus 6 into -5 plus 7. Then you get your answer as 12. So k it is equal to 12. Okay, k here it is equal to 12. It is equal to 12 there. Um, Determine the equation of the straight line passing through CD. Passing through CD from C. Let me use a different color. From C to D, CD like this, but it is a straight line passing, right? So it should pass. It should pass. All right, right? This is my straight line, right? So I know that this straight line has a coordinate here. Has this important points there of d is equal to -5 and 12. Let me rewrite it as d is equal to -5 and 12. And important coordinates here. Remember what is c? First thing that you have to write is the coordinate of c. So you have to find the coordinates of c. So the coordinates of c, you know it is 0, and what is the y-intercept? This value here, it is 7. Or you can just say for y-intercept, you let x equal to 0 is going to be -0 minus 6, 0 plus 7. You all agree with me that this is 7, right? So how do I get the equation of this straight line here? Remember, I should find the gradient first, right? So, but for my gradient, I know gradient of DC is going to be y value of D minus y value of C divided by x value of D minus x value of C. What is the corresponding y value of D? It is 12 here. Minus here, it is how much? It is 7. Divided by -5 here, minus 0. Then 5 minus -5, it is -1, right? Therefore, I know that, all right, I can either use this one, y it is equal to mx plus c. Then y I can take either this one or that one, but I'll use this one. What is my y? 7 is equal to gradient, it is -1, x it is 0 plus c. Therefore, I have y it is equal to what? C it is equal to how much? C it is equal to 7. Okay, so my equation is y it is equal to -x plus 7. This is my equation actually for this line here. All right, or instead of using this one, this method here, you can say no, the gradient is still the same. The gradient is still the same. So instead of saying, you're gonna say y minus y1 it is equal to m into x minus x1, right? So y it is whatever, y1 that we used, it is 7, right? -1, this is our gradient. X minus x1, you said it is 0. So it's gonna be y it is equal to -1 multiplied by x, it is -x. Then you take this 7 to the other side, plus 7. So whichever that you use, all right? Yes. So that's the answer there. That's the answer there. Our answer, it is y it is equal to how much? -x plus 7. I don't like this line. This line. Yeah, maybe I now like it. So here, our straight line, it is that one. So we are told that a tangent parallel to CD touches F at P. Determine the coordinates of P. So now this is a scenario of us having a graph and a tangent, a function and a tangent. Remember what happens is that they share the coordinates. So here will be the coordinates of P. I repeat, our function as well as our tangent share a coordinate, right? And at this specific point, the gradient is the same. The gradient of this line is the same as the gradient of this function. But what is the gradient of this function? It is the derivative, right? At this point, at P, our gradient, which is the gradient of the straight line, it is equal to the gradient of our first derivative. This is what we are trying to say. At this specific point, at P, right? So what we must do, we should find it. So let's see where that a parallel line will sit. If it is a tangent, remember tangent touches our graph once, right? So it might be something like this here. Remember they said it is parallel to um to DC thereof. So I'm gonna do something like it should touch here. All right, maybe something like this, maybe. Okay, this is my estimation of what this tangent will look like, and we are told that it is parallel. It is parallel to this. Let me erase this. It is parallel to CD. Remember, parallel lines, they share what? Parallel lines have the same gradient. Gradient is the same, right? So it means here for this equation, the gradient will be the same of S of this one. But what is the gradient of this one? The gradient is -1. So here we have negative x plus c, right? This is the gradient. But now I said at this point here, at this whatever point here where they touch, let's say this is point P. At this specific x value of rather our tangent, this is our tangent. Our tangent and our function f share a what? Share a, let's say at P, they share a point. They also share gradient. Actually, here they share a point. Here they have the same gradient. All right. At P, our f, at P, f and tangent. F and tangent, they do what? They share a point, which is point P. They also have the same gradient. So now, what is the gradient of our graph? We know that the gradient of a, let's do this. Let's say the gradient of tangent, it is equal to the gradient of CD or DC, because I wrote DC there, right? What is the gradient of DC? The gradient of DC is equal to -1. All right, we know these are parallel lines. Now, what is the gradient of f? What is the gradient of graph f? The gradient of graph f, you know, it is the derivative. What is the derivative of graph f? I think we found that one, but it's fine. We will rewrite this. It is -2x minus 6 using calculus. This is a grade 12 work. If you are doing grade 11, this is where maybe you are supposed to stop, maybe here. If you are doing grade 11 and watching this video, stop here, because from here down there you won't understand anything. All right, so just stop at 6.3. But if you are doing grade 12, this is for you. This is the gradient, right, of f of x, but at the x coordinate of P, at whatever x coordinate of P, what happens? F prime x, it is equal to the gradient of the tangent. I repeat, at this x coordinate, whatever x coordinate of P here, where they share a point, the gradient of the tangent, it is equal to the gradient of the function. This is what I'm trying to say. At x coordinate of p, the gradient of the tangent is the same as the gradient of the function. Therefore, I can say what is the gradient of the function? The gradient of the function, it is negative 2x minus 6. It is equal to what is the gradient of the tangent? It is negative 1. Then I can solve for that x value, that x value at p. All right, that x value at p, when I do my math there, I get my x value at p as negative 5 divided by 2. All right, negative 5 divided by 2. But how do I get f? So how do I get y? How do I get y? Remember this point, it is also a point on the graph of f, right? It is also a point on the graph of f, negative 5 divided by 2. And this is so true, because if I were to do this, you all agree with me that it is more or less somewhere here, because negative 5 divided by 2 is the same as negative 2.5. So you all agree with me that negative 2.5, it is greater than negative 3. So it is maybe this one, it is a correct prediction. All right. So how do I get my y? I get my y by substituting this x value to the original function, because it is still a point on the f of x part, right? I believe you are following. So I'm gonna say f of negative 5 divided by 2, it is equal to, I'm gonna substitute now. I'm gonna say negative into negative 5 divided by 2 all squared minus 6 into negative 5 divided by 2 plus 7. Then I punch my calculator there off. Therefore, I punch my calculator there off. I get negative into negative 2.5 squared minus 6 into negative 2.5 plus 7. Hopefully, I did not do any mistake. I get 63 divided by 4. Therefore, if my x value at p, it is negative 5 divided by 2, therefore my y value, it is how much? It is that one. Then I can go and say, therefore, the coordinates of p here in terms of x and y are negative 5 divided by 2 and what? And 63 divided by 4. Here, these are the coordinates of p thereof. You need this principle. You need to understand this. All right. Hopefully, I explain this in a manner that you understand. So the last question says, which is 6.5, for the value of. All right. Let's do this. Maybe I might need to erase this. Let me just erase everything. If needs be, you can take notes there. All right. Let me just rewrite this as t negative 5 and 12. E as having coordinates of negative 3 and 16. Then am I gonna do this C? All right, 0 and 7. How? How funny of us not to calculate the x intercept. But you know, for x intercept, you do what? You let y equal to 0. All right. Then using axis of symmetry, there it's fine. All right. Let's see. The question says now to us, for which values of x, will f of x minus 12 be greater than 0? You can rewrite this as f of x is greater than 12. So for which values of x is f of x greater than 12? Where is 12? Remember the coordinate here. It is 12 here. Agree with me? The coordinate here, it is 12. Why? Because this is the coordinate of d, it is negative 5 and 12. And we all agree on this straight line here, on this straight line there, the y value will be the same, right? So the question is, where will our graph f have, for which values of x will our graph have y values that are greater than 12? So you agree with me, as I go down, the y value is less than 12, right? From this portion, from negative 5 to infinity. from negative infinity to negative 5, my y it is less than 12, right? And even also from this point, the x coordinate here. How do I get this x coordinate? I might need it. So remember, axis of symmetry says this is your midpoint. If this is negative 5, negative 3, this is going to be negative 1. Negative 1. The x coordinate, let me write it here, negative 1 and 12. Why? Because if this is your axis of symmetry, remember x coordinate of E, it is equal to x coordinate of D plus x coordinate of C divided by 2. Why? Because it is at the middle of the 2 points here, right? It is the midpoint. But what is the x coordinate of E? The x coordinate of it is negative 3. It is equal to x coordinate of D, negative 5 plus x coordinate of C divided by 2. Then when I multiply here, I multiply there, I get negative 6. Negative 6 is equal to negative 5 plus x coordinate of C. Therefore, x coordinate of C, mathematically, I get negative 1. So this is what I mean axis of symmetry there, right? Therefore, um, therefore, I know this is negative 1 and 12, right? So now let's answer the question. Or from negative 1 going to infinity, from negative 1 going to positive infinity, from this point going down, can you see that the y values are less than 12? But in this portion, the y values are greater than 12. Why? Because here it might be 12, 12. Let's say when it is 13, 14, up to 16. This is the maximum value. Then here it goes back to 15, 13, whatever, then comes back to 12. So you agree with me that between these points here, between these points here, between where x value it is negative 5 and where x value it is negative 1, that your graph will have a coordinates that are greater or equal to 12. So, but the examiner says where they are greater than 12, so it is greater than here at negative 5 and negative 1, they are equal to 12, right? So it's going to be x at negative 5 and negative 1, they are equal to 12. But the examiner wants where they are greater, so we do not include that. We do not include that. So that's all. I believe you are following. So that's all for question 6. Let's meet again on question 7. Thank you.